So in this video, we are going to just look at one last example with function composition. So the kind of the pattern or something that we have learned so far is that if you have the following function calls. So let's say I've got a function f, I've got a function g, I've got a function z, and I have some input x. So let's just use red for x here, and if G consumes X and gives some output, and whatever is the output from Z of X gets consumed by the function G, and then whatever is the output from this function over here G gets consumed by F. This Haskell code over here is completely equivalent. If you were to rewrite this as F with function composition G, function composition Z. Okay, so you can think about this function over here, this entire function over here that gets resulted after applying these function composition operator consumes some input x and spits out some kind of an output which is completely equivalent to this piece over there. Okay, so now what we're going to do is let's say we're going to create a list of lists here. So let's say I create a list of list, and let's have 1 to 5 there. Let's have 3, 6, and let's have one more 1, 7. Okay, so I have a list of list, and again, this example is from your reading material that I've posted on Portal, which is from the book Learn You a Haskell. Okay, so I'm taking an example from there right now, and let's create this. Let's call this L. Okay, so the type of L over here is a list of integers. Okay, and all I want you to do is I just basically want you to go across. So let's look at a few of them over here. So the first list of lists is 1, 2, 3, 4, and 5. That's this piece over there. This piece over here is basically 3, 4, 5, and 6. And this piece over here is basically 1, 2, 3, 4, 5, 6, and 7. Okay, so all I want you to do right now is just ignore the head element. Okay, so we're not concerned with these heads here. Okay, we're just going to kind of ignore them. And for everything else, all I want you to do is I just want you to basically sum these up. So you're going to basically sum up. You're going to sum up these things over here. Then you're going to sum up these pieces over here, and then you're going to sum up this pieces over here, and you're just going to turn them into a negative number. So first, let's just sum them up. So for the first one, 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, and this piece over here gives you 6 plus 5 is 11, 11 plus 4 is 15, and this piece over here gives you 7 plus 6 is 13, 13 plus 5 is 18, 22, 25, and 27. Okay, once you get these sums here, just negate them. So this becomes minus 14, this becomes back minus 15, this becomes minus 27, and then you return back a list with these numbers, which is minus 14, minus 15, and minus 27. Okay, so write a function that does that. How would you put some code together? So what I can do over here is I'm going to say, okay, look, you still want back some type of list at the end of the day, right? So why don't I use a map function here? And I'm just going to create a placeholder right now. I'm just going to create some kind of placeholder, which is going to be the function that I'm going to pass in, because the type of map, again, just as a recap, let's just figure out what the type of map is. The type of map is it takes a function from A to B, it takes in a list of A's and gives you back a list of B's. Okay, so what I'm going to do is I'm going to call my function map. I'm going to pass in some kind of function, and let's just call f. Whatever the function f is, we're just going to call this function. It goes from A to B as an f there. Now what I have over here is a list of what it requires here is a list of A's. There's no constraint on A. A could be anything. A could be any type there. So let's pass in there a list of integers, which happens to be referred to by L there. Okay, so this L over here, that L there is basically referring to that list of integers. Okay, so what I've really done here, if you think about the map function, because there's no constraint on map, and because I'm passing in this L over here, which is a list of integers, this A over here has taken implicitly now is basically a list of integers. That's what A is now. So map now, in more in this context is basically it takes in a list of integers, gives you back some b, okay, and it takes in a list of integers and gives you back some b. But we also know what this b needs to be. We know that this b is supposed to be some kind of an integer because the output, the entire output that I want back is basically, so if I go back to my to this piece here, what I really want back as an output is this list of integers. So I already know that. Okay, so coming back over here, I can kind of refine this. I can refine this map here that it takes in a list of integers, gives you back a list of integers. Okay, and it takes in a list of integers as a, that's my this piece over here, and finally gives you back this list of integers. Okay, now what map essentially is doing is it's going to go into this list of integers. It's going to get each one of these guys out. It's going to pull each one of these things out from that outer list and keep on calling this function, keep on calling that function there. So the way I'm going to do this is I'm going to use lambda expressions, and I'm going to say, okay, look, this function over here is going to take in some kind of a list. It's going to take in some kind of a list there. Okay, and let's just say, let's just use pattern matching. That is going to take in x colon xs. Okay, and what I'm going to do here is once it consumes that some kind of a list there, I'm going to just say, do I really care about the head there? I just told you in just a few moments ago that whatever is the head, I'm just going to ignore that. I don't even want to consume the head. I'm just looking at the sum of the tail. So one way of doing that is instead of putting x there, let's just ignore that. We don't even need that head there. Okay, and we're just going to put some parentheses here just to make it clear that that's my function there. And what this function is doing is taking in this some kind of a list, but I'm ignoring the head. Whatever the tail is, I mean, whatever excess is, I will sum up that portion of the list there. How would I sum that up? And well, one thing I could do is I could just say sum excess. Okay, I sum it up, and after I've summed this entire thing up there, I'm going to say, all right, I just need to take that take the summation and then finally negate it. Finally negate it. Okay, and whatever is the output of this is then is going to this is a function that goes from a to b, and I need to pass in a list of a's, and the list of a's basically is my L there. So let's just try this. So if I try this, what I get back as an output over here is minus 14, minus 15, and minus 27, and this is exactly what we wanted earlier. So if I go back to what I had earlier, I wanted minus 14, minus 15, and minus 27, and this is exactly what I see on my let's see my code over here. Okay, I see the output minus 14, minus 15, and minus 27. Okay, so far so good. I mean, this is one way of putting the code together. But is there a way where I can clean this up a little bit? Okay, now to clean this up a little bit, what I could do is I could first say, let's use function composition. The pattern that I see over here is negate of sum of excess. So whatever is sum excess, the entire output gets fed as an input to the negation. So what I can do over here, this is a really good candidate for function composition. So while I'm doing this is let's use function composition, and whatever the function is going to take an excess, and let's try it out. Then use the parentheses. So negate sum and excess. Let's see, 1. Okay, I'm missing one extra parenthesis there. Okay, there you go. So I get back minus 14, minus 15, and minus 27. This is exactly the same thing that I did earlier, but now I'm just using function composition. Okay, do I really have to use pattern matching there? Well, I don't have to. I really don't have to use pattern matching. It just makes that code simple there. But if I say, okay, look, what if I don't use pattern matching? I'm just going to say whatever that list is. Let's just store that list in X there. Okay, and or more specifically, let's say XS. Now, because XS contains the entire list, and from that entire list, all I want is just the tail portion. Well, why don't I do something neat? Why don't I say from this XS, okay, which is the entire list, okay, meaning it's going to contain every single one of these things. So it contains, so the first time it's going to be from 1 to 5, then it's going to contain 3 to 6, and then it's going to contain 1 to 7, as map keeps on calling this over and over again. So now, because I'm not using pattern matching, I'm going to say, okay, on this entire list XS, first get me the tail portion of it. The tail portion basically returns back to you a newer list. What does tail do? Let's write the type signature for tail. So tail basically is this function that takes in a list of A's and gives you back a list of A's, such that from this original list as an input, it just takes the first element out. Whatever is the remainder of that list gets you back. Meaning, if you have 1, 2, and 3, and you call tail on 1, 2, 3, you get back this new list which is 2, 3. Okay, this element has been taken off. All right, that's what tail is. What does sum do? Sum says, okay, give me back, basically in this case, a list of integers or some kind of a number there, and gives you back an integer. Okay, and what does negate do? Well, negate. The way negate works is the type signature for negate. So let's just cross this out. We don't need that. We don't need this piece here, and we don't need this tail there. Okay, so negate says, okay, look, give me back some kind of a number. Okay, some kind of a number, and I'm going to give you back the negation of that number. So if this is a positive number, I give back a negative version of that. If it's a negative, I give back a positive. Okay, so let's see the types match up. First thing, is there any constraint on A? Well, there's no constraint on A. A could be anything. So in the context of this problem here, let's make that, instead of saying A there, let's just make this as an integer, a list of integer, and instead of saying A there, we're going to make this as a list of integer. Okay, so what does tail do? Tail first consumes this input. It consumes this consumes this input excess, which is this piece over here. And tail gives you back a list of integers. Tail gives you back a list of integers. That list of integers is consumed then by sum. Sum over here consumes that list of integers right there. It then consumes in that list of integers and gives you back an integer. Whatever integer you get back from sum is then fed into negation, which is this piece over here. Okay, negation takes in that input and then finally gives you back another integer. Okay, so the types completely match up there. Okay, and because types match up over there, what I'm going to do now is this entire piece over here. What's the type signature for this entire piece? Well, the type signature for this entire piece over here is basically, it's a function that goes from, that's the input, a list of integers, and it gives you back an integer. So this entire piece in blue has the following type signatures. Okay, can I show that to you a little bit more explicit from Haskell? Well, I can. So let's do that. So before, let's just first run this code, okay, and we get back the same output. Now I'm going to say let f equal to negate sum tail. Okay, what's the type of f there? And there you go. That's exactly what I had earlier. So on my last thing, what I had here was from a list of integers, the entire type of this piece in blue. Entire type of this piece in blue is from a list of integers giving you back an integer. And that's exactly what I have now, where this f over here is basically the same function negate sum tail, and the f, whatever this f is basically has a type signature that goes from a list of integers giving you back an integer. So can I clean this code up a little bit? Well, one thing is I can definitely get rid of this entire piece there. I don't even need this entire piece there. And I can just say f, and that gives me back the same output, because the function f is exactly what I have on my code there, which f is basically this entire piece there. Okay, and whatever this f is, I'm basically passing in as a parameter to map. Okay, but can I take the entire thing and put it in place? Can I use everything in line there? Well, absolutely, I can even do that. So coming back over here, I can place that and say negate sum tail, and that's my entire function f there, and you get back the same output. Okay, so I hope this was a bit useful in getting a good grip on what function composition is, and so again, just do a lot of practice, and if you have any more questions, I'll be more than happy to clarify that.